going to learn how to find the greatest common factor in algebraic terms. Before we get to the algebra, let's remember how to factor. And in particular, I want to look at two different kinds of factoring. You'll recall from early years that when you're looking for prime factors, the best way to find your prime mates are in a tree. So if we ask for prime factorization, that's what you do. You build your tree. Now, my suggestion is to always start with the smallest divisor. If it's even, start with 2. And then break your number down, always putting the smallest divisor to the left. And you'll notice as you read down and then over, you have all your prime factors least to greatest in one spot. You don't have to go hunting for them in the tree. They're right there in cages. So that's why I do it this way. Now on the right side is another method for factoring, and I call it ends to the middle, because you start with 1, and then of course 1 times 60, and then you go to 2 times 30, 3 times 10, and eventually these numbers are getting closer and closer together until you get to the last 2 factors of 60, which are 6 and 10. We know 7 doesn't work, 8 doesn't work, 9 doesn't work, and now you're at 10, so you're done. So I call that ends to the middle. It's helpful to know that factor trees don't always show all your divisors. Here I've used a factor tree and I have my primes over here for 24. And if I were looking for all the divisors of 24, I would not find 8 or 4 in that tree. Working ends to the middle, I would see the 4 and I would see the 8, but I wouldn't see that there's 3 multiples of 2. So each of these factor methods have an advantage. In algebra, it doesn't matter whether you use the prime factors or ends to the middle, but when you're looking at the variables, you will see very easily what the prime factors are. And for that reason, let's use primes. So when I'm looking at 64, here's my prime factorization. Where did I get this list of 2 times 2 times 2 times 2? Well, I broke it down from a tree. So you could do that if you wanted to do that. I just made the list. Here's the first one, and then I'd have 2 again, and so forth. And the same with the 12. This is 2 times 2 times 3, which I got from a factor tree. Well, once you've got your primes for your numbers, look at how easy it is to factor the variables. Well, x to the first power is just x, and y to the second power is y, and so forth. So to find the greatest common factor with this method, all you have to do is look and see what you have in the 2 prime factorization. You've got a 2 and a 2. Oh, look, there's another 2 and a 2. And then with the variables, you've got an x and a y and an x and a y. That's it. You're going to take the 2xy from here and the 2xy from there, and that is your greatest common factor. Oh, that's just 4xy.